Hello students, in the previous class we have discussed about the numericals on the kinetic energy. Today we are starting with the next topic, that is the law of conservation of energy. Okay. Now in this topic we will study that energy can neither be created nor be destroyed, but it can be converted into one form to another form. Okay. So what is our today's topic? Law of conservation of energy. Okay. In this topic we will study about how there is a conservation of energy, and we will be taking some example to solve it. Okay. Now what is the statement of the law of conservation of energy? According to law of conservation of energy, energy can neither be created nor be destroyed, but okay, what does it mean? Law of conservation means the energy can neither be created nor be destroyed, but we can convert those energy into one form to another form. Okay, so this is the statement of the law of conservation of energy, and this states that, as we have done in the chemistry, in that was the energy can neither be created nor be destroyed, but it can be changed into one form to the another chemical form. But here we are changing that, it is changed into one form to the another form. Example, within the electric cell, if we take the example of electric cell, okay, or we can consider as a battery, you can say that the chemical energy inside the cell or the battery, what is present? Chemical. Okay, that chemical is present, and that energy is stored in the chemical, that will be called as the chemical energy, and that chemical energy is converted into electrical energy. Okay, when we switch on, okay, when you switch on the circuit, what happens? That chemical energy is converting into the electrical energy. Okay, and then it is converting into the light energy, which will be passed on to the circuit if it is connected to the bulb. Okay, so this is the energy conversion, we can say, to glow a simple bulb. Okay, you can consider a bulb in which you can glow that bulb in which when you are connected to the cell or the battery, because the cell contain chemical, and that is the energy stored in the cell is in the form of the chemical energy, and that chemical energy is converted into electrical energy, and then the bulb, it is glowing. So we can consider that it is converting into the light energy. Now similarly, example we are considering, a person riding a bicycle. Okay, when a person is riding a bicycle, okay, now when we are doing any activity, we need energy, and for energy what we do? We take food. Okay, so when we are taking the proper food, it means the chemical energy is stored in the form of the food. Okay, so in our body the energy is stored in the form of chemical energy in the means of food, and that food changes into heat and to the muscular. So when we are doing exercise, our body temperature is increasing. Okay, and what it is providing? It is providing the muscular energy, and here we are taking the example of a bicycle. So all this activity, what it will lead? It will lead to change into mechanical energy. Already we have studied about mechanical energy. Mechanical energy is the combination of kinetic and potential energy. So what is how it is applicable here? The person is sitting on the bicycle, so he is having the potential energy, and when he is applying its energy on the bicycle is moving. So together both the energies are working. So we'll consider here which energy? It is the mechanical energy. So whenever the person is riding a bicycle, what happened? The food which we have taken, that is the chemical energy of the food, it changes into heat, because we are doing exercise or we are working here, so that will be converted into heat, and that heat will be changed to the muscular energy, and together it will lead to the mechanical energy. Okay, so what we have studied this topic, law of conservation of energy. What is the statement of the law of conservation of energy? According to law of conservation of energy, energy can neither be created nor be destroyed, but it can be changed into one form to the another form, and two examples we have taken here. First is the electric cell or the battery, in which the chemical was there, and that chemical energy, when we on the circuit, convert into electrical energy, and the bulb again it will glow, it will glow and forms the light energy. Similarly, riding a bicycle, we have taken a proper food, that is chemical energy, and when we are riding the bicycle, it will change into heat and muscular energy, and finally you and the cycle together, the energy would be considered as the mechanical energy. Okay, now the next topic we are studying about average power. We have already studied. Okay, so we are studying about the average power. Now what is the meaning of the average power? When different amount of the work is done in different interval of time. It means you are doing work, okay, but you are doing work in a different interval. So together power, if you want to consider, what you will be doing, you will take the ratio of the total work done to the total time taken. Okay, so this is the definition of the average power. The ratio between the total work done to the total time taken will be called as the average power. Okay, so the definition of the average power we can write, it is the ratio, it is you have to divide what? Total work done upon total time taken. And since the work done, it is equivalent to the total, it is equivalent to the energy, so you can also say that it is the total energy consumed divided by total time taken. Okay, so this is the average power. Power means already we have done work done upon time. Here we have to consider average power. Average power means when you are doing the different works in the different interval of time. So if you want to add all those work and all those time, it can easily done with the help of the average power. So what formula you will be using? Total work done upon total time. Okay, so this is the formula of the average power. So in today's class we have discussed two topics: law of conservation of energy, in which the energy can neither be created nor be destroyed, but can be changed into one form to another form. And one more topic we have considered, that is average power. When different amount of the work is done in different interval of time, we can consider the average power. Okay, so average power, it can be calculated by the formula total work done divided by the total time. Okay, or you can consider the total energy consumed divided by the total time taken.